Hi, everybody, and welcome to the DocumentDB Insider Hour. For our return viewers that are pretty observant, you'll notice that I am not Doug Bonser, your normal host. Now, whether that's a good thing or a bad thing, I'll leave that up to you. But, Doug, if you're watching, your show's in good hands. Maybe. I'll censor all the feedback we get at the very end. But Doug is on vacation. We occasionally let him step away from the desk, and I'm going to be filling in for him today. And with me is Tim Callahan. Tim, I will let you say hi.
Hey, how are you, Cody? And
I'm good.
and I think our astute viewers will also recognize um, something happened. Like, did you run out of closet space for your sneakers?
Oh gosh, yes. I ran out of closet space a long time ago. I ran out of space. I ran out of floor space. I need to be careful because my wife might be watching this. But yes, space is at a premium right now, especially for shoes. All
And
right.
I'm in my third home office in 2 years.
You
Moving.
have a fan behind you.
I
Little
do.
hot there in Boston?
Yeah, it's warm.
Warm. It's 115 in Dallas. It's warm here as well.
Nice.
Thinking about making some cookies outside on the sidewalk. I had a friend that did that. He put a cookie pan with cookies on his dashboard in the parking lot when it was like this outside, and it kind of worked. I mean, it we had them out there for like 4 or 5 hours and they looked like cookies. They were still pretty gooey, but it still kind of worked. But anyway, so today, what we're going to do is we're going to talk about the execution engine and indexing, and not just indexing basics. We're going to kind of deep dive into indexing a little bit. Um, Tim and I, because we didn't properly introduce ourselves, we're solution architects for the DocumentDB team. What that means is that we regularly sit with customers and talk with them about their workload, how they can make their workload faster, how they can make it more performant. We talk about new features, which we have a really cool new feature that Tim's going to show us here later. But we talk about how we can make these workloads more performant, how we might be able to change things to make them, well, better, for a lack of a better word. One thing that comes up a lot, especially over the past year, is cost optimization. What can we do to cost optimize our workload? Tim, I'm DBA by trade. I come from a background of DBA. I know that you're more of a programming side, developer side, but and I'm kind of curious about this too because I know what my answer is for this. I'm curious if you approach this the same way. But the answer for me as a DBA back in the old days was we'll just throw more resources at it. If something's going slow, add more RAM and CPU and hard drive space. Is that the developer approach as well?
Well, let's be honest about what your DBA approaches were. It was always let's throw another index on it.
Well, right, but when I ran out of space to add more indexes, I had to throw more hardware, right?
True. Yeah, I always took as a developer the approach. I've been a benchmarker in optimizing things probably for my entire lifetime back to programming on a Commodore 64 in assembly language and in ML actually. And I always came back to, you know, can I make something a little bit faster? Can I make something a little bit faster? Because I always felt that if I make it faster and then you scale the resources, it's a multiplicative approach there, right? We're getting all even better goodness out of the technology that might be able to be put in place. But yeah, absolutely. There were times where storing a lot of extra redundant data made a query much faster, and you just paid the penalty somewhere else, like the checkbook having to put. I think at the time in a Solaris server, the drives were like nine.
Solaris
They
server.
were like
Wow.
yeah, they were like 9 megabyte drives, I think. And you just have trays and trays of these drives to be able to hold that much data. So there's always an interesting trade-off.
You didn't just misspeak. You said 9 megabyte drives, right?
Yeah, I think the early Solaris systems I worked with were MB. Yeah,
Nine. You know what? I'm gonna go on eBay later and see if I can get one of those. I mean, they have to be like 3 cents or 4 cents right now.
yeah,
And
they
I'll
were
make
probably
you a
3,000 from Sun back in the day.
Oh yeah, that's true. Yeah. But I'll get it gilded and put it on like a big old gold fake rope chain and you can wear it around your neck. OG, right?
Yeah. Well,
So
and then the other great part, we're going to talk developer to DBA here. We'll use that as the backdrop for this conversation. We'd go out and we'd get 10 of these drives and they'd get put in the Solaris server. and the sysadmins would format them and
So
add them to the
10, a
array.
full 90 megabytes we're talking about. I
Yeah,
just
so
want to
like
talk about the
all that
scale.
stuff got done, and then what did the DBA do? He allocated, because I was using Oracle at the time, he gave me, a tenth of it. And until I'd filled up 90% of that tenth, I didn't get the next tenth. And occasionally we'd run out of space, and it was, better to just give me a little bit at a time, because if you give me all of it, I'm going to use it immediately. Like
You
that was
didn't deserve it yet. We had to vet you. We had to make sure you knew what you had. It's like you don't give your kid the full 1 pound bag of Skittles. You give him a handful, and if he doesn't kill himself, you give him a couple others, right?
yeah, yeah, the old unable to extend table space error in the middle of the night that would page you. I don't miss those days.
I'm getting feedback from the chat room that I need to get you a RAID controller to wear. Did you have a RAID
Hey,
controller for 9 megabyte drives?
hey, as long as it's battery backed.
There you go. Nice. So going back to the topic, that same mindset is still applicable even in modern applications, right? Throw more hardware at it. This time it's virtual hardware. What we'll see, what I see with DocumentDB customers, and Tim, I'm sure you've run into this a lot, is customers will over provision their workload. DocumentDB has the benefit of having the compute layer and the storage layer separate. You have the compute layer that works independently of the storage that you actually don't interact with at all. Like there's no GUI or CLI or programmatic way to interact with storage. It auto scales and auto shrinks for you. It auto repairs. It makes sure that you're spread across 3 different availability zones. But what you do have control of as a customer is that compute instance layer, those compute instances that sit on top of the storage layer. And what I see customers do is they'll, instead of running on an R6G large, they'll say, well, I need a little bit more horsepower, or I need to add more indexes, or I need to add this new aggregation. I'm going to run a 2XL, for example. And you can do that, right? Just like the old days of adding 10 more 9 megabyte drives to your Solaris, as one does, as we all have done, right? You can add more CPU and RAM to those instances as well, but that's not the cost optimized way to work to run your workload. um a lot of times you don't have time to think about that, right? There's situations where you just need to push something out, and increasing instance size is a quick fix. But what I want to talk about is how you investigate your workload, what tools you can use to investigate your workload to make it more cost optimized. I'm going to show you a lot of tools that I actually do with customers, and Tim, hop in as I show these, and let me know where you might do something different, or where I might be missing something. But let's just go ahead and hop into it, and hey, there's my desktop. All right. So what we're going to do is we're just going to start interacting with our document DB cluster. I have some clusters set up in my AWS account. We're going to be using our brand new DocumentDB 5.0 set up on some T4G mediums, and we have it set up with 2 instances. So on my Windows desktop here, I have a couple tools that are going to allow me to interact with DocumentDB. Just for ease of use, I have a couple of shell commands set up that take me directly to it. The first one I'm going to use is what's called the legacy Mongo shell. This is, if you look at our user guide, or if you've done getting started guides from our developer guide, this is one that you'll be familiar with. This is something that we use a lot, and it's basically the green screen, right? The black and white CLI. But this is pretty useful because I can come in here and I can say, show DBs, and I can see all my databases, and I can say, okay, use my customer data database. And then if you're like me and you like to take shortcuts, I say show my tables, or if you do it the way you're supposed to, show my collections. Once I do that, I can do operations like db.customers.find1. And here I have my record. So that's my select star from table, just interacting with the data, just the basic way that I would interact with that. What's cool here too is that if I need to investigate my current operations, I can use the current op API command. That current op is going to show me information like, hey, somebody's connected to my DocumentDB cluster and they're running something. As a matter of fact, there's somebody that's running a db.current op right now. think I know who that is. I don't need to investigate that further. But the other cool thing here is if I do show my collections again, I can get statistics about my collection. So if I do my db.customers.stats and use that stats operator, I can see information like how many documents are in that collection. What's the average size? These are all in bytes. I can see what the average document size is, number of indexes, things like that. A lot of really useful information. Now, a really cool thing about this is in these shell commands, I can actually run JavaScript. So I just ran my db.collection.stats, but I want to see my stats for, well, I want to see it for all my collections. So what I'm going to do is fight with copy and paste for a second. And I'm going to say iterate through every single one of my namespaces, my collection in my DocumentDB cluster, and return back to me how many documents are there, what the size is, what the storage size, the indexes, and total index size. So a lot of flexibility in it, right? So if I want to interact with it, it makes it really, really easy. Now, MongoDB also came out with MongoDB Shell, which is the new version of Shell.
Cody, before you go there,
Yo,
one thing that's worth talking about, because I don't think we need to blog about it at some point, I think. Go back to your other, where you did your stats call.
sure.
Now would be a great time to cover it.
You want me to run that JavaScript again or just the DB dot?
No, just the one off for the customers collection.
Okay. Let me use the right. Yep.
So what was added, kind of, it was added about, I think, 3 or 4 months ago. But if you look, there's some interesting things we've added to our stats, that you can get some of this in prior. But for example, op counters, right? We're keeping track of inserts, updates, and deletes, and that's just a counter that gets incremented and it goes back, resets to 0 when the server restarts. But sometimes we'll ask a customer, how many updates per day do you do on collection foo? And one way to know that would be to take a sample of it today, take a sample of it in 24 hours, subtract the two to get, how many updates
Oh, yeah.
actually occurred. And that's not easy to get otherwise without running through a change stream or the op log. The really cool one is just below it, the cache stats, and that's giving, that's letting you know when this collection you did a find, right? So if your find was able to get the collection out, the document out of the cache, it comes out of call blocks hit, meaning it was in memory. Otherwise, call blocks read, which means we had to go to do IO, and that gives us a hit ratio. And then if we did index access to get it, was the index done entirely in cache, or did it require an IO? What's our cache hit ratio? And these cache stats are also available at the index level with the aggregation list indexes command. You don't need to run it right now. But what's super cool about that is, when people look at their systems, they see, hey, my cache hit ratio is 98%. I feel really good, or it's dropping to 93%. It's very easy in these systems to holistically get that very, very high level number. But we're giving you access to the details here. So you can really go deeper than, the classic, let me see if this index is used. Well, it's nice to know it's used, but it's nicer to know while it's being used, how effectively is it, in memory versus being needed to be read somewhere else. So it was a
And you're
really, we
talking
got
about
to write a
the,
blog about this, because it's really, I think, a great feature for customers who want to dive deeper on how is their cache doing? Like, should I go upsize to a bigger instance, or which of my collections are causing the most harm to my hit ratios?
so instead of looking at the big picture across my entire my entire cluster, I can now get the individual statistics there.
Yeah, down to the collection, down to the index.
In my, I don't know if you knew this,
Yeah,
but my
you're a
cluster's,
Superman. I don't know how you got 107% cache hit ratio.
ESP, it just knows beforehand. We have a relationship, my cluster and I. We know each other. It finishes my sentences, finishes my queries, I should say. So yeah, no, this was released gosh, I can't remember, a couple weeks ago, a couple months ago. Both the ops counter and cache stats. What we're gonna do here, I have a question for you. So the exercise that we're about to run through, I'm gonna go into the specifics of collection scans versus index scans and why you'd pick one or the other. Walk me through a scenario where somebody would want to use these. Like, what is a scenario where a customer is looking at their workload and says, I need to go look at those cache stats for this namespace for X reason? What's that reason?
Um, well, the question you tend to ask a customer, or I at least do, right? When I'm first meeting a customer, looking at their workload, we might be talking about a migration or how we can cost optimize. The the rule of thumb is always let's do a complete overview of your indexes on all your servers, your primary and your read replicas, or your primary and your secondaries, right? And at the index level, let's see how many times each index has been used, right? That's number one. And then number two, we can also look for index redundancy, right? If I have an index on A in one index, and index two is A comma B, then the index strictly on A is redundant. We can use the A comma B index in its place. So one would hope the data should bear that out. If that existed in a real customer's use case, then index A should have zero usage unless they're hinting. And if they're hinting, that brings with it its own dilemma about potentially dropping the index. So we can start at a very high level with let's do some sanitization. Should you be dropping these indexes? And you got to make sure you look at your read replicas because they do queries as well. Do you have redundant indexes? Do you have unused indexes? Let's clean that up first. Then we can dive a little deeper to see, the index usage. Has this index been used 3 times in the last 3 months? Probably a mistake. It might be something operational. It might be something that doesn't have to really be running in milliseconds, maybe running that query for a minute in the background. It's not a user facing query, so not a big deal. And then lastly, it comes down to this, which is I can have all these indexes that are great and they're being used, but you really don't want your index cache ratio, the hit ratio to be requiring any IO whatsoever. So if at all possible, you want the working set of all your indexes to be fitting in cache. And when you drill down to this level and you showed some JavaScript that'll help customers easily get down to that level, you need to then start looking at if an index is used a lot and when it's used, it needs to go to disk. That's kind of working against yourself. Indexes are
Right.
there to make things fast. IO is not nearly as fast as reading from memory. So using an index a lot and having that index need to do IO is not a good thing. So you want to try to that might be an example of you have to give up some indexes to make some space in the cache, or you might need a bigger instance type to do less IO.
And I think, that's a good point and that's obviously the separation compute and storage with DocumentDB is a huge benefit is not having to manage those two. But when you spill over to disk on DocumentDB, well, there's actually a network layer between the compute instances and the storage layer. So since the storage is not directly attached to the compute, there's a network hop there. So anytime that you're spilling to disk, yeah, there's the IO part of it, but that means that you're adding a network hop to that data going back and forth. So that's increasing your latency when an index is supposed to decrease it, right?
Mhm. And before you go, we actually did miss up above a little bit call scans and IDX scans. Like
Oh, yeah.
I forgot we put that in too. That's huge, right? If I've got a 400 gigabyte collection and I do one call scan, that you're waiting. That better not be a user facing query. So
How
those
much is
are,
that gonna be?
great candidates for investigation, and it's we keep track of it and we expose it. I think it's kind of an area where we're trying to bring new features and observability to document DB to make it easier for customers. It's hard to know unless you have the profiler enabled and you're going to scrape through all those logs to find call scans. And again, call scans, do I care if it's a 100 gigabyte collection? Yes. Do I care if it's got 5 docs? Nope. It should be call scanning a 5 doc collection. So
Right.
lots of interesting opportunities here for us to build more tooling around these metrics.
So what we're gonna do is we're gonna move from the macro level, and we're gonna go into the micro level because that's exactly what we're gonna talk about, is we're gonna talk about those index scans versus collection scans and how you can kind of control those. Tim mentioned hints. We're gonna look at that. Going into the new MongoDB shell, well, first of all, you can tell it's better because it's pretty. It has colors. It's easier to see. But here, we're doing the exact same thing that we did with the legacy MongoDB shells. We're doing our show DBs, but you can see here It's auto scaling our collections. Before, when we had the legacy Mongo shell and we said show DBs, everything's just in gigabytes, right? But now it's going to auto scale that for us. You have some control over that, but it does it for us. So we'll use customer data. We'll say show tables, and we'll say db.customers.find one. And there we go. It makes it a little, again, it's just visual. That's the nice thing about this is our keys are one color, our values are a different color, and you can see our different value types have different colors. The cool thing here is you can't see my fingers on the keyboard, but trust me, it's doing it. Watch. C U tab. Tab. There we go. Customers autocomplete, right? So now I can autocomplete certain operations. And the other cool thing about this is error finding. It does some error finding for you. I don't think that I've ever written a MongoDB statement correct the first time. So this is very helpful. This is very handy to have that. So here we're doing all the same things that we did before. We can look at our current op, and the current op, we actually should have been reviewing the current op in this because, well, again, you can see the different colors a little bit easier. Let's look at our stats because that's what we were just looking at. We're going to say db.customers.stats, and let's run this. And guess what? It doesn't work. MongoDB shell is the newer version of the command line interface for MongoDB. It's constantly being new updates are constantly being released. I think at the time of this show, it's on version 1.9. It might be further than that. But what's happening is as they're releasing it, is they're MongoDB's optimizing these commands and operators, or optimizing the way that you run DB, the stats operator. One way that they've done that is to get certain statistics from their collection. They've added this collection stats, this col stats operator. That is an operator that currently isn't supported in DocumentDB. So when it tries to call on that, it's not supported. We have a full list of all of our APIs that are compatible with MongoDB and DocumentDB in our developer guide. But I think the important thing to point out here, and we've talked about this before, is DocumentDB is not MongoDB, right? We're just emulating the response a MongoDB client expects from a MongoDB server. Behind the scenes, we're completely different. We are a completely different engine. We're going to see that today as we go through the execution engine. But again, we're not a drop-in replacement. I'm sure there are certain use cases where if you have a workload that's running on a different document database server and you want to move it to DocumentDB, you can just change the endpoint and it'll work. However, never, ever, ever do that. Test, right? Always go through and test. Always make sure that your application works. And these admin commands that you're running are actually working. This is a great example where you could move over and you think that everything is working great and your application's perfect and everything is working as expected. But you go and run this stats command because your third-party tool uses it or your DBAs use it and it doesn't work, right? These are the kind of things that you want to test. So just be aware that there will be certain differences between legacy Mongo shell and the new MongoDB shell. Today, though, what I want to do is I want to use a management studio, a GUI, something that makes it easier to interact and visually look at my data, almost like a SSMS for Microsoft SQL Server. The one we're going to be using is the NoSQL Manager for MongoDB Professional. Now, there are a lot of different GUI tools out there. You have MongoDB's Compass is an excellent tool. Studio 3T makes a great tool. dbeaver is a great one. What I like about the NoSQL Manager is it seems to have the best compatibility with DocumentDB. It just works. It supports all the commands and operators that we need. You can go to their webpage and maybe we can send these links out. Doug's gonna have to show me this when he gets back, but we can send the links out for this. But it's mongodbmanager.com. It's a NoSQL Manager, and we'll just kind of go through the rest of the show. Well, I'll go through the rest of my part going through this. The first thing that we'll do is connect to our DocumentDB cluster. Now, when you connect to DocumentDB, by default, we're running in replica set. There's no such thing as a standalone DocumentDB. So we have to connect in our replica set mode. And our replica set members, we just put the cluster endpoint, not all the individual instances, because This is using I believe it's using the C# driver. It's going to auto discover all the members. I'll show you that in a second. Replica set name. Well, there's only one replica set name. It's RS0. Read preference is a whole topic that we won't talk about in this show, but you should use secondary preferred, best practice. We're going to use username password authentication. A couple other things that we're going to have to set up is our SSL options. DocumentDB is secure by default. Data at rest is encrypted and data in transit is encrypted. And this is using a PIM file. So what we're doing is we're telling the NoSQL manager to use this PIM file whenever it makes its connections. And I'm lazy. I don't want to type in the password all the time. So it's going to remember my password. Once I do that, I double click it and there we go. One thing that I will point out, I think I think that it's important to note here is the Amazon workspace, the machine that I'm on right now, is actually within the same VPC, within the same private network as my DocumentDB cluster. DocumentDB is a private VPC endpoint only service, meaning that if I want to connect to it like this, I have to exist in the same IP space as it. There are ways to connect to it through, well, SSH. You saw that there was SSH options built into NoSQL Manager. They actually have on their webpage a walkthrough of connecting to DocumentDB using these SSH options. So just want to point that out, that for today's show, I am actually in that same private IP space. Once I'm in here, I have a lot of information that's at my fingertips that I was pulling from command line. For example, if I look at my user trips collection here, immediately I can see properties. I can see my indexes that are on it. If I want to take a look at my data, well, I can take a look and see what my data is, and I can change the view of it. I can say, look, show me a document view, show me a table view, or show me the native JSON view that a Mongo shell would show me. And again, I have my stats, my db.usertrips.stats that has all those values that Tim was just pointing out to us. So a lot of useful information here. The other thing that I really, really like about this is we have a SQL editor. I come from the background of relational databases of SQL Server, of T-SQL. What the SQL editor does, it lets people like me who can't write MongoDB write statements like this, and it works against DocumentDB. It translates. I'm not going to run that one because that's actually going to take a while. So let me run this one. I have a query here, and it's going to do a select top 10 user ID in this field fair for my user trips with a couple of orders in there. I'm going to run it. It's actually going to execute that statement for me. So it's not just translating it. That's one of the things it's doing, but it's actually going to run it and return the results. But what's cool about this is if I run the statement view, it'll actually show me how I can run that if I was running in Mongo shell. So if I took that command, I came back over here, I ran that command, and I used customer data. I pasted that command. It's not returning anything, but it's correct syntax. It's not complaining. It's not yelling at me for it. So a lot of really cool features built into it. And of course, Mongo shell. And that's what we're going to be using for this. And this is just Mongo shell built into this tool here. So we're going to talk about that execution engine, how DocumentDB is choosing to run a query. We're going to start off by just running a very simple query. We're going to say, look at my user trips table and find me just a single user. Find this user 567160. You can see it took a while, right? Nice thing here is at the bottom, it shows us our execution time and it shows us how many documents we got back. So that one took 2.2 seconds to grab 3 documents. That seems a little concerning. Why did it take so long? Because I don't think this is a large collection. I'm going to go back to my user trips and stats. I have about 2 million documents in there. So 2 seconds seems a little bit slow to me. So what I'm going to do next is I'm going to say, okay, let's run an aggregation against that user ID. I want to look at that user ID, find that 567160, find all their trips they made in 2023, and return any that where the distance they traveled is greater than 3 miles. So if I look at my data while that's running, I can see, well, it should look at these two because these were in 2023. They were both greater than 2 miles. So it should be adding up that fair value. So I should have something about 16. And I do. There you go. I have 16 records back. But again, it took a while. Why did it take so long? Well, DocumentDB supports the explain uh, operator, and the explain operator tells you it asks the engine to tell it what execution plan it's using. If we go back to this find command and I do explain, I add it to the end here and I run it. Just running explain by itself is just saying, don't actually run the query. Just tell me what execution plan the engine will use. Whenever you run a find command or find one command against DocumentDB, it's the very first time it runs, it's going to create an execution plan and it's going to reuse that plan for any subsequent queries that have a shape that's similar. What I mean by that is it chose to use this plan for this query. If I come in here and you look for user ID 1 or 2 or 3, well, this is just a parameter. And it's going to say these are all the same shape. So I'm going to use that same execution plan I have. And whether it uses an index or a collection, it's going to decide that. Now, there's certain things that will trigger DocumentDB to pick a new execution plan. We're not going to go into that, but generally that's how it works. With aggregations, running an execution or explain aggregation, sorry, running an explain operation against an aggregation is slightly different. You're not going to run this at the end of the find operator. You're actually going to run it at the beginning before the aggregation. So let's do that. Let's run this. The difference here is I'm adding this parameter called execution stats. And what this means is don't just tell me what execution plan you're going to use. Use it. Go actually run the query. The difference between find operations and aggregations in DocumentDB is we don't reuse execution plans for aggregation. So if I run this query again, which I will, it's not going to reuse that execution plan it just picked. It's actually going to figure it out again. All aggregations will pick a new execution plan every single time. So if I look in here, I can go down and I look at my execution stats. This is what it actually ran to give me my data back. And I can see that, well, there we go. It did a collection scan. It went through 2 million documents to give me 2 back, and that took 1.7 seconds to do. And then it had to add those 2 up and do some math, and that part took about 0.16 milliseconds. So it took a little bit of time to fix that. All right, cool. So very, very simple DBA hat. We know how to fix this. We create an index, right? What we're going to do is we're going to go back to our user trips. We're going to look at our properties and we're going to come in here. And we're going to say create a new index. Again, you can do this through command line. I'm going to do it through this interface here. There's a concept called it's an ESR role. I'm not going to explain that. Tim, what does ESR mean when we talk about indexes?
ESR, what are you trying to trick me here?
Yeah, I am.
I don't know what ESR means.
Equality, sort, and range. So when we're creating our indexes, order matters. Very straightforward example is if my query is looking for first name Cody, last name Allen, and I don't have an index. Well, I want to create an index and I want to start that index. The very first field I want to put in that index is first name because that's what I'm searching for first. I'm looking for first name first, then last name. So that order is very important. But equality, sort, and range is an order that we follow for that can help us with these type of aggregations. We want to create an index that puts those equality fields first. So that first name, last name first. Then we want to add our fields in that we're sorting on, right? So sort by age, sort by favorite Amazon purchase, whatever it is. And then finally, the last field should be range field. So show me where this year is greater than this value or less than this value. So we're going to apply that equality sort range concept to the index we're going to build for this query. So we're searching for user ID. Oh, look at that autofill. I love it. So the first thing we're going to look for is user ID. And the second thing that we're searching for, remember, is trip year. We're saying where trip year is 2023. We're going to do both these ascending. It doesn't really matter at this point. We're not sorting by anything with this aggregation, but we are doing a range. Remember, we're saying a range of miles greater than 2. So we're going to say add miles to that. I like to put some kind of verbosity to my index name. So I'm going to say user ID trip year. and then miles is the name of my index. Add and continue. This is going to build our index for us. Again, you have a lot of options in here with the NoSQL Manager. We're not going to use those today. One thing that's cool is while that's creating, look at that percentage, 32% done, 58% done. Tim, I think you're going to talk to us about that later because that's really, really cool. We didn't have that before.
And something to be mindful of, Cody, right? Sometimes like using an IDE or a GUI like this, you need to be careful, right? Building an index. I didn't see a property on there for foreground versus background, but
correct.
Yeah, but you got to be, always test and really pay attention to what you're doing there, so you don't make the collection go read only in production while you're building an index.
And so what we're talking about there's default values, right? There's default properties that maybe one GUI will select and another doesn't. If you do a foreground index build in a DocumentDB system, well, that blocks all operations, whereas background will allow operations to continue. All right, so we ran our query and we didn't have the index and it took 1.7 seconds. So let's run the exact same query now that we have the index and see how it works. Holy cow, look at that. A whole lot quicker. 0.035 seconds to return the 2 documents, right? So our index was perfect. It did exactly what it's supposed to do. It found that user ID, it found the trip year, it did the sort. It actually took longer for it to do math to return that data back to us. Cool. Now, one thing I'm going to point out is our developer guide. Developer guide has a section called functional differences. Just like we have supported APIs, we also have a section that talks about functional differences. And one of these topics is, well, here I'll just read it. Amazon DocumentDB does not currently support the ability to use indexes with not equal, not in, not or, not, basically negation operators, right? As a result, they're going to do collection scans. So my query, if it's using, instead of using an equal to, it uses not equal to, it's not going to use a collection scan, or it's not going to use the index. So let me do that real quick. Let me go and change my query a little bit. And I've modified it. And now it's going to say user ID is not equal to 567,161. Perfect. So if I run this, it's going to take that 1.7 seconds. I'm going to get my result. I'm going to scroll down. It's going to say collection scan. Wait a second. Why does it say index scan? It told me. I just read the manual. We read it together that it's doing a collection scan. Why did it do an index scan? The execution engine, every time you run a query, it's going to look at that query with that aggregation. It's going to decide what's the best way for it to return data. DocumentDB is keeping statistics on your collection. How many documents it thinks it has, what's the cardinality of those documents. And it's going to do a determination as what's the quickest way to return data back to you. In this case, it looked at it and it said, based on the data I have, even though you did a not equals to, I still think an index can get that data back to us quicker. So what happens if I do a negation on 2 fields? So now I'm going to say that I am not equal to that value, and I'm not equal to 2023. So clearly here, we have 2 negations on equality field. You would think that it's not going to use that index anymore, right? And if we look down here, there you go. Now it said, I really don't have enough information to help you out through that index. So I'm just going to do this collection scan here. What I want to show you is why. Why did it think I need to do an index scan here versus a collection scan here? So let's kind of break apart our data real quick. The first thing I want to do is let's look at our user ID and look how many trips our user ID, this user did in 2023 versus 2022. Let's see if that's what it was using. So in 2022, we have 1.3 million trips, and in 2023, we have 607,000. Well, that doesn't match these values that it used to narrow those down. Okay, so let's break down our entire collection by year. How many trips were done in 2022 and 2023 versus each, and then how many were less than 2 miles and how many were greater than 2 miles. And here we should see small miles is going to be less than two and big miles is going to be greater than two. Oh, there we go. So in 2023, there were 312,000 trips that were greater than 2 miles. Well, that's why it used an index, is because instead of going through 2 million documents, it knew that it had 312 that met this within the index. And that met the threshold of using the index. It said, okay, I'm going to use this index because based on the data I have and the statistics I have, I'm going to get data a lot quicker. If we look at this, where it could not use user ID, it could not use user year, the best it could do is see that it had this this many trips in 2022, because remember it can't use 2023. It had this many trips that were greater than 2 miles, which is the only part of that index that it had to use. And it determined, well, you know what? It's not efficient for me. It's not going to help me to use that index and go through it to find the 714,000. It's just quicker for me just to go back to that collection and find that data. This kind of ties to cardinality. This is a big reason why you want to make sure that you have very high cardinality indexes, or you're indexing values that have a lot of unique values, right? Some kind of personal ID number or a date with a timestamp to it. Those are unique values, because if you don't, even though you might have a lot of unique values, but you have a high propensity for one, right? So you have a database that has all of the parking tickets for the university, but 80% of that database is Cody Allen, maybe a true story. It's going to say, yeah, those are all unique values, but 80% of those are Cody. So I'm just going to do a collection scan. It doesn't make sense for me to use the index. So let's see if the engine was right. Did it choose correctly? And what we're going to do here is we're going to go in, create a new shell. And Tim mentioned using the hint operator. And what the hint operator does is it says, that's cool, execution engine, that you decided that you want to do an index scan or collection scan. But I'm going to tell you specifically, use this index. And this isn't just for collection scan situations. This could be, you think that this other index that maybe you already have or that you want to build, you think that this would help out your operation, and you want to tell the execution engine, use this index specifically. So what we're going to do is we're going to say, not equal to that value, not equal to year. And remember, same as we did before, but this time we're going to say, use that index I created, because I am a human. I know better than you. I'm smarter. It's going to be faster. So now that I'm running that, let's go back to the collection scan. And this process took about 7 seconds when it decided to do that collection scan. And when I told it to use that index, well, now it took 6 seconds. So this is a situation where the execution engine is doing everything it can to make the best decision about how to return your data back. These statistics are being updated. There's a whole series of triggers and catalysts for those statistics updating and for it to go back and review those. Remember, aggregations are always going to go back and look at those statistics, whereas your find operators are going to, use the same one that for find operators are the same shape. But this is why it's important to dive into these, do these kind of operations. You look at those explain plans, use hints, create new indexes, try to find that, change the order of operations on these, because this is where you're going to get that performance. This is where you're going to say, all right, engine, I think that this is a unique enough workload that this is going to be a lot better. I know that I have this other index here that you want to use, and that index is for this workload, but use this one specifically. And that's all I wanted to show. I think that those were all the commands that I wanted to show through this one. Tim, anything you wanted to add?
No, this was a good overview. Like you mentioned, right? Like if you live in a if you have part of your use case, you use first name, last name. And let's say you have a search need in your application to find Cody Allen or Tim Callahan. Um, if the use case is you always provide both first and last name, then the order of those fields in the index is really uninteresting. Doesn't really matter.
Right.
But generally, if you think about the problem, if you're going to do a sort, you're probably going to sort on last name first, right? So be mindful. Like you might be optimizing for the search, but be thinking about things like sorts as well. So You definitely, in that example, you could have an index first last or last first. The find is going to be quick either way, but a find with a sort, you need to be thinking beyond. And that's again where you explain execution stats while you're building your app, every single query with a lot of good sample data, right? Look at it all up front. And there's nothing wrong with a hint. I wish they called it hint a command because it's actually not a suggestion, it's a requirement.
Right.
Hinting is great because it pins the execution plan. The one downside to a hint is if that index for any reason doesn't exist in the future, the query will fail. So
Right.
it isn't just a suggestion; it is a command. So there's a pros and cons to most things in databases, and that's one. I'm a fan of hints if you really know your workload and you don't think 10 years down the road someone's going to throw in a new index that might make this query better. It's not a bad thing to put hints in your application.
I think aggregations make it a lot more difficult. You know, it's easy to do these kind of things, hints and explains with find operators because they seem very straightforward, right? But aggregations, what I see with customers is this confuses things. And so it makes it harder for you to determine how to build a good index against an aggregation. This is exactly why you want to do it. That's why you want to use those hints and you want to just try it out, right? Like Tim said, don't just do this on a sample size of one. You know, if we had a collect, this was a pretty small collection, and if we only had like 1,000 documents in here, I guarantee you all of these operators and outputs would have been a whole lot different. So, Tim, I have left you with like very little time to go over the cool thing, the fun thing, the exciting thing that we hinted at. So I will turn it over to you.
Sure. Can you turn on my screen share? So just 2 weeks ago, I believe, maybe last week, we deployed new versions of DocumentDB 4.0 and 5.0, and a couple really interesting marquee features. One is compression. We'll do a follow up Twitch show to talk about how we've added compression, the trade offs, how to enable it. We'll share some tests and some benchmarks to look at some numbers. The other big feature is relating to indexes, and that's it's called faster index create in the launch announcement, but it's basically parallel index create. So we're going to give you the ability to build your indexes faster through parallelism. And with that feature, there also comes I'll call it a sub feature, and Cody had a little hint to it in his demo, which is prior versions of DocumentDB. When you say create index, it blocks like in your Mongo shell, it just sits there. And at some point in the future, maybe in a second, maybe in a day, the index is built and the the um, the operation returns. And if you did a current op, you got you knew you were building an index, but you had no sense of progress. So adding progress reporting, and that's a DocumentDB 5 only feature. That's not part of 4.0, is also important because the bigger your collection, the longer the index build, the more anxiety I think you can get when an index build takes hours, depending on the size of the collection. So, to talk about it briefly, the why and what's going on under the covers. In deploying this new feature, we increased the documentation around index create, and there's essentially four scenarios. When you're creating an index, it's either done in the foreground or the background. Um, Background is important if you're in production and you're not in a maintenance window. A foreground index will block, so it builds the index, and while the index is being built, no insert, update, or delete operations are allowed on the collection getting an index. And in the background, that's not true. You can build a background index on the fly, and it doesn't block any inserts, updates, or deletes from occurring. And then there's whether the index is unique or not. It was worth documenting because it does add, we'll call it a stage here. So we just wanted to make sure we documented all stages for both foreground, background, unique, and non-unique index builds. The most common scenario I would say is going to be the background um, uh, non-unique index build. And if you look at the stages, right, most of these are no different in this new release of DocumentDB than they were prior. You need to initialize. Um, you've got this building index initializing. Um, Stage 3 is the big one. That's scanning the collection, right? Cody was just showing you collection scans in his tests in his demo. To build an index, you have to walk the entire, we'll call it the heap, right? All your documents are just a big blob of data. You're building an index on first name, last name. We have to visit each document to extract the first name, last name, and then have a pointer to get back to that document when we build this index. So scanning the collection was far and away the longest stage in the index build process. And in prior versions of MongoDB, DocumentDB, we only used a single thread for that scan. So just like a query in DocumentDB is single threaded, um, building an index, same thing. So if you have a 100 GB collection, one thread has to read all 100 GB. 10 TB collection, one thread has to read all 10 TB. And then beyond stage three, it goes back to entirely single threaded. So what we changed in stage three is the ability for the customer to dictate how many threads, or we're using the term workers here, will be used in this collection scan. And collection scans are very, very linear, right? If I can scan a collection in an hour with one thread, then it's going to take, give or take, about 30 minutes with two threads and about 15 minutes with four threads, right? It's a very easy process to understand the throughput of stage three, which is the most important thing to be um, looking at here. Um, these stages are also, again, they're well documented here. And in DocumentDB 5.0, when you're building an index, you're actually able to see what stage the process is in. And then for most stages that are interesting, that have like duration, you're going to see that within the stage. So this collection scan, we're going to tell you how many blocks have been read and how many total blocks there are and what percentage of 100% completeness we are on stage three, for example. Um, Considerations before we do a quick look at how this runs. Number one, it's only available in 4.0 and 5.0. Progress information is 5.0 only. Um, we only let you enable this feature on a 4x and a 4XL and above instance type. It's important, right? There's a limited amount of resources the smaller your instance, and we didn't want customers building indexes at the cost of really affecting their running production workload. And then the trade-off, right? If you use more threads, you're going to use more CPU to build an index. It's not much because it's a lot of waiting on I/O going on there. But you're going to increase your read I/O while the index is being built. The more parallel you go, so just something to be mindful of. Run a test. Clone your DocumentDB production cluster. Run a test of this to see how much it'll impact, and look at your workload before you run this. If you're at 99% CPU, you've got a different problem, but probably don't want to be doing an 8-thread index build at the same time. You still want to probably build indexes in the more, when your cluster is more lightly used, maybe in the middle of the night if you have an application that's really busy during the day.
Sounds
Um,
like it's really hard for us to say what the impact is on CPU because it's completely contingent on your data set and your
mhm.
workload. Like what's the impact? Well, it could be anything, right? I mean, it could be absolutely nothing or it could be substantial to your workload.
Yeah, and the biggest impact will be the read I/O. If your
Right.
if your application is really doing a lot of reads, and to be careful, right? We have storage has IOPS and bandwidth, right? We have to go get the data. So the the smaller the instance types, again, that's why this is limited to 4XL and above. Is you could consume a lot of bandwidth if you had 16 worker threads, collection scanning a 16th of that collection at the same time. If you look at my screen, I, like Cody, have prepared for this with a couple examples. I have a collection here I'm calling call 2048 bytes. It's a 2K average doc size with 25 million documents. And I'm going to make sure I don't have my index in the way, called some field one. Um, to build an index using this feature, it's extremely simple. Build a create index command. You still give I like, just as Cody did, give your indexes a name that you decide. Don't let the system just make up names for your indexes. There's a new parameter here called workers. If you don't supply workers, you'll get 2 workers by default, again on 4XL and above. And that means compared to DocumentDB of 3 weeks ago, right, the new version, your indexes will always build twice as fast if you don't supply workers. You can still say workers colon 1 and go back to the old functionality, just one thread. We default to 2. Workers is allowed to be up to 50% of your vCPU. So I'm on a 4XL. I've got 16 vCPUs, so I can do workers 8 here. And if I say go, in my other window, I can do a current op as Cody was showing there. And here you can see the new message field because I'm running DocumentDB 5. I'm scanning the collection, so I'm in stage 3 of 5. Um, that's how many blocks I've read so far. That's how many blocks are total. So 57.69% complete. Do it again. Now sorting the keys. And in a moment, I'd expect to get a response from my index build process over here to say that it's built. This is a small example, but in this example, I have the real numbers. With 8 workers, I'm able to build this index in 57 seconds. Again, 25 million docs, 2K average doc size. So it's a 50 gigabyte collection. I'm on a 4XL, it's in memory, right? So this is a fast test, but it's good to see how parallelism helps. So with 8 threads, it's under a minute. 4 threads, it's a minute and a half. 2 threads, it's 2 minutes. With one worker, the old behavior, it was almost 4 minutes. So almost, very, very linear in terms of how it drops down the timing.
An
Um,
index build is
what
only
really I
a
think is stands out is if you look at it.
no, sorry, go ahead, go ahead.
Go ahead. So to show this at for some different scenarios here, right? So here's an index create test where I said I'm going to create the same amount of data. I think this was also 50 gigs, and my average doc size varies from 1K, 2K, 4K, 8K, right? So my 1K test, I'm going to have 50 million documents. My 2K test, 25 million documents. I kept the overall size of the collection the same, but the row counts reduce as you get bigger. And you can see here it scales with all document types, right? On the small example here with 1K, it took 700 seconds to build it with one worker. It took 210 to build it with 8 workers. One worker, 8 workers, right? You can see this kind of walking its way down in terms of performance. The really compelling one to me is, right, we support 32 terabyte collections, 128 terabytes per cluster, right? Some of our customers have extremely large collections and they want the flexibility to be able to add an index. And they don't want to wait 2 weeks, right, for that index to be built. So the final test I'll show here is this is a 10 terabyte collection with an average doc size of just over 8 kilobytes. And in old DocDB form with one worker, it took, these are days, 15 days to build the index on that collection at that size. And you can see here with just 2 workers, right? I've cut that in half to 7.5. With 4 workers, 3.74.
It's a linear
Cody knows
cut
I like
across
to
the
do
board.
things like this. I can build it in a day. This is on an 8XL, so I'm allowed to go to 16 workers, right? So in 0.96 days, I can build that index now compared to 2 weeks. And I'm a hacker, right? I wanted to overclock. So I said, what if the team behind me, they turn off the governor. Let me have as many workers as I want. I did one more test with 48 workers. So it's a 32 vCPU, but if I could do 48 workers and down the road we might, decide that we can raise that governor to a different value. I built that index in 8 hours, right? 0.33 days. So I think it's pretty phenomenal to see this kind of feature where it just needs resources, right? So this isn't to say that the customer using this can afford 48 workers of load on the server doing that collection scan concurrently, but certainly seeing how it easily brings down these numbers. Like just by default, if the customer does nothing, it cut it in half, right? You're going to get 2 workers by default. So awesome new feature. 5.0 is better than 4.0. I will keep saying that anytime I get a chance, because again, having the progress, right? I was also the DBA at times on that Solaris box, and in Oracle back in the 90s, they didn't have progress, right? I think I got progress in the mid 90s in Oracle, maybe late 90s, but not having index progress as a DBA, it just was unnerving. Create index. Well, I hope I
The
screened into that.
unknown.
Yeah, I hope I use screen on that SSH session because I don't know if I'm going to stay connected for 14 days,
That's
right?
awesome. Well, we posted a link in there, so you can read more about it. Again, just a reminder, 5.0 only feature. This is something for 4XL instances and larger, but check it out. We're gonna have this video available up on YouTube, and I think it's gonna be available on our Twitch show. So if you want to go back and review it, go check it out. But Tim, thanks for joining us. Thanks for walking us through it. Had a blast. And Doug, we miss you. Hope you have a safe trip back home. Thanks, everybody.
So long.